So today what we're going to do is we're going to talk about vectors in the coordinate plane. And so first of all, vectors can be written in two forms. They can either be written in component form or linear combinational or IJ form. So first of all, component form, if you notice there, okay, uses kind of the arrows. And you have 2, -3. Now basically what that means is that the horizontal component is 2 and the vertical component is -3. So when I think about that, horizontal means x, okay, vertical means y. So if I was going to graph a vector that had a horizontal component of 2 and a vertical component of -3, it's going to go to the right 2 and down 3, okay? Now linear combination or IJ form is pretty much exactly the same thing as component form, it's just not as neat, okay? It's got the I and the J. You can see that the 2, 3 here, that is how we would write it in linear combination or IJ form. Okay? Now, if I had this -7i plus 5j, what would that look like in component form? -7, comma 5. Okay? So component form is generally the easier of the two, just because you don't have the I and the J. But we're going to be looking at numerous things today. So first of all, we're going to talk about the magnitude. The magnitude is nothing more than the length of a vector. Okay, now I'm going to let you go ahead and get that down, and then we'll talk a little bit about it. So first of all, the length of the vector, if you notice the very first formula, it looks real similar to the distance formula that we learned. Okay, except for in place of P and Q, we use X and Y. And basically what that means is that's just individual components of each individual vector. So for example, this is if I would have vector P1, P2, and the second vector Q1, Q2. Okay, that's where those come from. And so basically what I'm doing is I'm taking Q1 minus P1, so that's like the x's, and then Q2 minus P2, which is like the y's. Okay, this is the formula that you will probably use more of, the V1, V2, and we'll talk a little bit about that. Okay, so our first example says find the component form and the magnitude. I have an initial point of 4, -7, and a terminal point of -1 and 5. So the first thing I need to find is I need to find the component form. So the component form, if you remember, is the one that looks like this. And so what I need to do is I need to find each individual component. So if you notice, I go from 4 to -1. So going from 4 to -1, I have really went, I've went a -5. Another way you can find this, -1 minus 4. You always start with the terminal point and you always subtract the initial point. Okay? So let's go ahead and look. Initial point, I start at -7. I end at +5. So really, what have I done?
5 minus -7.
5 minus -7, which is +12. Okay? Another way you could view that, what do you do to -7 to get +5? You add 12. So there's your component form. Now what we need to do is find the magnitude. So to find the magnitude, I'm going to actually use the second formula this time because I have each of the individual components of vector V. And so to find the magnitude here, all I'm going to do is square -5 and I'm going to square 12. And then I need to solve that. Okay, so once you've found that component form, I can go ahead and solve it that way. So squaring -5, I get 25. Squaring 12, I get 144. So what is 25 and 144?
169.
169. Square root of that is 13. So that is what the magnitude of V is. Okay? So let's go ahead and look at this one. This one says find the linear combination of the vector that has initial point 2, -5 and terminal point -1, 3. So linear combination, remember, means I and j. So what we're going to do is we're going to once again do the exact same thing we did before. We go from 2 to -1. So to find the net result, I'm going to take -1 minus 2, which is what? So my I component will be -3i. Then I'm going to take 3 minus -5, and my component will be what? 8j. And there you go.
Is it always adding? Oh, wait, I guess it depends on what the number is.
Okay. All right, so far so good? Okay. Now this next one, I wouldn't even write down, because honestly, we're going to be through this slide before you can even get probably half of it written down. So first of all, if I see that vector v is -2, 5, and vector w is 3, 4, we need to find 2v. So what do you think 2v would look like? -4, 10, and you're exactly right. All you do, oops, let's make sure that's a 1. Okay, all you do is multiply each of the components of v by 2. Okay, what do you think is going to happen with w minus v?
1.
Okay, so w minus v says I'm going to take 3 here minus -2.
5.
So 3 minus -2 is 5. Then I'm going to take 4 minus 5, which is -1. That is what w minus v is. You just do whatever operation it asks. And then v plus 2w. You already know that v is -2, 5, right? Okay. What is 2w? 6, 8. So now to find the answer, I'm going to go ahead and just add components together, and I get 13. And there you go. So pretty straightforward. Alrighty, so now we're going to do the same thing except for we've got linear combination form. Find 2u minus 3v. So to find 2u, I'm just going to go ahead and multiply each of those by 2. So what will that become?
-6i
Plus 16j. Now on the v, I'm going to actually make that a -3v. Okay, so to make that a -3v, what's that going to become? -6i, okay, plus 3j. Okay, so then now, if I go ahead and add like terms, -6i and -6i is -12i.
Right?
Okay, 16j, 3j is 19j. And there you go. Questions? Okay, we've got two other things we're going to finish up with. The first one is what a unit vector is. A unit vector is nothing more than a vector that has a magnitude of 1. When we define the word unit, it just means 1. And so how we find a unit vector is we take whatever the original vector is divided by its magnitude. So I'll let you go ahead and get that down, and then we'll look at an example. Alrighty, so it says find a unit vector in the direction of v equals -2, 5. Find a unit vector in the direction of v equals -2, 5. So the first thing I'm going to find is what the magnitude of v is. So from the previous slide, I know that that's going to be -2 squared plus 5 squared. So what is negative 2 squared plus 5 squared? So really, my magnitude is root 29. So now to find a unit vector, I'm going to take, oops, let's try that one again. To find the unit vector, I'm going to take vector v, which is negative 2, 5, and I'm going to divide that by the magnitude of v, which is root 29. So essentially what that means is that each of these are divided by root 29. So I now have negative 2 over root 29. And I have 5 over root 29. But you already know that I won't accept square roots in the denominator. So that's not our final answer. Well, yep, so what will our final answer be?
Negative 2 root 29 over 29.
Negative 2 root 29 over 29. And then 5 root 29 over 29. So that will actually be your final answer. Okay? So that's how you find a unit vector. We've got one final thing to do, and that's to find the direction angle. Okay, so we're going to find the direction angle of each vector. So that first vector, u equals 2, 9. The best way to view that is to draw a visual for you so that we can kind of see what's going on. And I'm going to assume that that vector is starting at 0, 0. So a vector of 2, 9 means I'm going to go to the right 2 and up how many? 9. Okay? So that is really what my vector looks like. So now I want to find the direction angle. So I want to find this angle right here. So to find that angle right there, I'm going to go ahead and label some sides. What side is 9? Opposite. What side is 2? Adjacent. So what trig function ties in opposite and adjacent? So I know that the tangent of theta equals opposite over adjacent. So now on your calculator, you're going to have to find the inverse tangent of 9/2. And that angle comes out to be 77 point what? 49. And there you go.
77.47.
47? Okay. Questions? We're going to do the same thing on the next one, except for this one's written in IJ form. Okay, so IJ form, 3, -4 means you do what from the origin?
Over down, over 3 down 4.
Over 3 down 4. So I'm going to go over 3 here and then down 4. And so I need to find this direction angle. Now a direction angle actually in this case will be from here to here. Okay, but I really need to find that little angle first. So to find that little angle first, I'm going to go ahead and use tangent. So tangent of theta equals what over what? 4 over 3. So when I go ahead and calculate that, I get theta to equal,
You always do the inverse tangent?
In these problems, yes.
53.13.
But that is 53.13 is the little angle. I don't want the little angle, so what am I going to do?
Take it minus 360.
Yep, 360 minus 53.13.
306.87.
So 306.87 degrees. And there you go. Questions? There's your assignment then, page 497, 2 through 30 to the evens, 44 through 50 to the evens, and I would expect a quiz tomorrow.